Let's just make sure we know different symbols that we'll encounter. So here's a cell. Okay, as a cell, it's represented by a little line, big line, like so. There's a space between. And we have our wire going to left and right. Battery is just multiple cells put together. So here's an example of a battery. You could have like small, big, small, big, small, big. It can go longer. Kind of depends on how accurate you want to be with your diagram. If you know that battery is made up of 4 cells, and you draw like 4 of them all next to each other. A voltage source, sometimes we're not using batteries, we might just have like something that provides voltage. You can just draw like a circle with a plus and minus on each side. Wire, it's just a line. Connected wire, if you have like 2 wires that are connected, oftentimes we'll put a dot there, or if we don't see anything, we just assume they're connected. If you want to show 2 wires that cross but aren't actually connected, usually what we do is draw a little bridge like so over top. Ammeter, big A, so this measures current. Voltmeter, big V, measures voltage. Let's just scroll down. So there's our ammeter again. Here's our voltmeter. A resistor. Sometimes we see it with the little bumps. Resistors are often just seen with like a little rectangular box as well. A variable resistor, you may not see these, but it has a line through it. So these ones are usually just like it's a resistor that you can usually has like a screw that you can turn or something. It'll actually change the resistance. A light bulb, just another example of a very specific type of resistor, because resistor is anything that that consumes potential. Light bulbs are going to consume potential, resistors consume potential, but actually has a function. So the function of a light bulb is to create light. A stove is like a light bulb, but a stove's purpose is to create heat. A fuse, so these are usually little pieces of wire that are designed to burn out. Usually if too much current is being drawn, you guys will be using ammeters in class, and if you allow too much current to pass through an ammeter, you'll find that your ammeter no longer works. That's because you blew the fuse. At that point, you have to go to our lab tech or talk to the teacher, and we have to actually physically put a new fuse in. And houses, you kind of have fuses, but they have those switches. So I don't know if you've ever drawn too much current and suddenly the power went out, and then you or your parents had to go down and go to this box somewhere in the house and flip some switches. So those switches act as your fuses for the house. So if too much current is being drawn to a particular socket, the switch will automatically flip, preventing any more current to pass through. A switch, and this is a open switch, or you can draw it connected. And lastly, a galvanometer. We'll probably be using this in our final unit 8. It just has a little arrow because it's basically a very sensitive ammeter, and often just like swing to left or right, telling us the direction of current.